Let's learn about the future technologies. Let's learn about the future. Welcome to Hyperfocused Engineer.
Close your eyes. A friend hides a coin somewhere in the room, and your job is to find it blindfolded. You take a step. Colder, they say. You turn, step the other way. Warmer, warmer. Freezing, you back up. Little by little, one word at a time, you close in on the spot you can't even see. You never knew where the coin was. You just knew which way was warmer, and you kept stepping that way. Hold on to that game, because that is exactly, and I mean exactly, how a machine learns. Right at the start of this series, we said every model learns the same way. Guess, check how wrong you are, adjust over and over until it fits. We drew it as dots on graph paper and a line trying to settle through the middle. Today we pop the hood. We're going to watch that line actually learn, step by step, and you'll see there's no magic inside. Just warmer, colder, so what can our line even change? Only two things. It can tilt steeper or flatter, and it can slide up or down. That's it. Two dials. Picture them as two little knobs on the desk. Every straight line in the world is just some setting of those two knobs. When we say the model is learning, all we mean is, it's hunting for the right setting of two knobs. That's the whole machine. Now, how does the model know if a setting is good? Remember, our examples come with answer keys, the real prices we already know. So we draw a little pencil ticks, the gap between the line and each real dot. A big gap means a bad guess. We add up every gap into one single number. That number has a name, the error or the loss. Small number, good line. Big number, bad line. One number for how wrong am I right now. Here's the beautiful part. Imagine every possible knob setting spread out as a landscape, and the height of the ground is that error number. Bad settings sit up on the hills. The perfect setting sits at the very bottom of a valley. Learning is just walking downhill. At every step, the model asks, which way makes my error smaller? Which way is warmer? And it nudges both knobs that way. Warmer, warmer, downhill toward the bottom. But how far do you step each time? That's the learning rate. Take giant leaps and you fly right over the valley and miss it, bouncing side to side forever. Take tiny baby steps and you'll get there, but you'll crawl. So we pick a step size that's just right, big enough to move, small enough to land. And one full walk through all your examples has a name too, an epoch. One epoch, one pass over everything. Let's do it. Start with a wild line, a total guess, way off the dots. Add up the gaps, the error is huge, say 100. Step downhill. The line tilts a little, the gaps shrink, error's now 60. Step again, 30. Again, 12. The line is tipping and sliding, hugging the dots tighter each time. Warmer, warmer, warmer. After enough epochs, the number barely moves. We've hit the bottom of the valley. The line has settled through the middle. It learned. And here's the payoff. Our line had two knobs. ChatGPT has billions. But the recipe never changes. Measure how wrong you are, then step the way that's less wrong over and over. That's it. From a pencil line on graph paper up to the biggest AI on Earth, same loop, just more dials. 30-second recap. Training has 3 moves. 1. Guess. 2. Check how wrong you are, add up the gaps into one error number. 3. Nudge the dials downhill so that number shrinks. Repeat until it stops shrinking. Not magic. Just warmer, colder until the line fits. Want to see the valley move? 3 blue, 1 browns, gradient descent shows it beautifully. StatQuest's gradient descent, step by step, walks the numbers slowly. And Andrew Ng's course goes deeper still. Next episode, this loop only works if you feed it the right stuff, so we'll talk features and data and why garbage in means garbage out. Subscribe and let's keep going.